Good morning, college tricksters. Today we are going to continue working in Chapter 5, Section 1. The notes packet that I'm going through is the one that is labeled Day 2. If you look at what our goals are for today, you're going to notice that we are going through a lot of different review topics from the first part of 5.1. Our goal is just to become more confident. Some of these problems, they're kind of tricky when you're verifying and when you're simplifying, and the more you practice, the more confident you will get. So as we go through these, I just want to make sure that you remember you will be needing to refer to the little table from the first day of 5.1. It's labeled Fundamental Trig Identities. Today, you are going to see situations from all 5 scenarios. You're going to have some reciprocal identities. We're going to look at some cofunctions, Pythagorean identities, even and odd functions, and our quotient identities. So as we're working through and simplifying and rewriting various things, this little table is going to be super handy. If you look at our plan for the day, today is just a day to go through and do notes and practice. Okay, there is no assignment. It is a lot of information. The notes are going to take a little bit longer than the previous videos. So grab your popcorn, your Milk Duds, your soda, hang on, and let's go to it. Number 1, we are looking at how do you simplify trig functions. If you are simplifying a trig expression, the ultimate goal is to try to get it down to only one trig function. So if I'm looking at number 1, I actually have 3. I have a sine, a cotangent, and a cosine. So I need to use those trig identities in order to simplify this down to where I only have 1. I'm going to start off, I have a sine of t plus. Now for cotangent, there's 2 things that I can do here. Okay, I can rewrite it as 1 over a tangent, or I could have cosine over sine. Considering my other trig functions are sines and cosines, I'm going to try this one. Let's say I try this one and it doesn't work, I don't get anywhere. You can always go back and do it again and use your other identity. Okay, I'm going to start off saying, all right, cotangent, because of the quotient identities, is the cosine of t over the sine of t. Now that's being multiplied by the cosine of t. So the first thing that I did is I changed my cotangent into cosine over sine. Now you'll notice I have adding and I have multiplying. Order of operations, you always multiply first. This is a fraction. If you're multiplying fractions, it's top times top, bottom times bottom. That's why I put a 1 on the bottom, because I can go cosine times cosine, sine times 1. So I have sine of t plus cosine times a cosine is cosine squared of t. Sine of t times 1 is sine of t. Now what we're looking at is adding. This is a fraction. You cannot add fractions unless you have a common denominator. This denominator is a sine. This is a 1. So in order to make a common denominator, I need to multiply top and bottom by the sine. Sine times sine is sine squared. Our variable is a t. Sine of t times 1 is sine of t, plus my other fraction is cosine squared of t over sine of t. Now when you're adding fractions, if you have a common denominator, that carries on over to your answer. So the sine of t, we're already halfway done. On the top, these are not like terms. This is a sine, this is a cosine. So when you add them, you end up with both the sine squared of t plus the cosine squared of t on the top. This is a Pythagorean identity. If I look, this tells me the sine squared of theta plus the cosine squared of theta is really a 1. So this is really a 1. My numerator has a value of 1. My denominator is a sine of t. 1 over the sine of t indicates that I'm doing the reciprocal of the sine. The reciprocal of the sine in trigonometry is the cosecant of t. There is number 1 simplified. Super fun. Maddie Olson, I can tell you're loving it. All right, number 2. Now, number 2, we are going to see a cofunction. This right here, when you see pi divided by 2 minus x, that's a cofunction. So we're going to go ahead and look at that area in our table. I have a cotangent of pi divided by 2 minus x. So if I notice, or I look for that in my little table, cotangent of pi divided by 2 minus theta, this is the same thing as a tangent of theta. These two things match. The only thing that's different is here they used theta as your variable. Here we're using an x. So this means that I can take my cotangent pi divided by 2 minus x and replace it with the tangent of x. This is fun. Okay, check this out. So this is the tangent of x. Then I have the cosine of x. Not done. I can definitely go further. Quotient identities. Tangent is sine over the cosine. So I can go ahead and tangent is the sine. My variable is an x over the cosine of x. I'm multiplying by the cosine. Hey, if you ever multiply something by its denominator, it cross-cancels. All I have left is the sine of x. You can't simplify the sine of x any further. Number 2, done. Number 3. Now, number 3, the first thing that I notice is, hey, I have a sine squared and I have a 1. And so as you get used to this, hopefully one of the first things you would think of is, oh, sine squared of x plus cosine squared of x equals 1. That's one of the Pythagorean identities. And the reason why I thought about that, looking in the parentheses, is I see a 1 and I see a sine squared of x. I can take this sine squared of x and I can minus it to the other side. So I'd have cosine squared of x equals 1 minus sine squared of x. Hey, this matches this. So what that means, because they match, I can replace this with a cosine squared of x. These two things are equivalent to one another. So in my trig expression, I can go ahead and replace 1 minus sine squared of x with cosine squared of x. So my new problem is secant squared of x times cosine squared of x. Again, I'm not done yet. I want to simplify it as far as I could go. A secant is the reciprocal of the cosine. Because it's squared, when you do the reciprocal, that power of 2 stays there. You're multiplying it by a cosine squared of x. Check this out. You're multiplying by the denominator. Everything cancels. You simplified that thing all the way down to a 1. So how cool is this? If you have a secant squared of x and you multiply it by 1 minus sine squared of x, it actually has a value of just 1. Super cool. Okay, the next example. So you know how they always have rules, and whether we're talking about any subject area, when they have rules, there's always exceptions to the rule. Number 4 is going to be that for us today. When you're trying to simplify, your goal is to get it down to one trig function. Number 4, we're going to simplify, and we will get it to a point where we can't go any further than 2. So it is going to be an exception to the rule. As soon as you see a pi divided by 2 minus x or theta or whatever variable, that is a cofunction identity. This is squared. You're going to do the same thing. You're going to figure out, okay, the cosine of pi divided by 2 minus x can be replaced with what? But you have to make sure that you square that value. I am looking for a cosine. It's right here. So cosine of pi divided by 2 minus theta. That can be replaced with a sine. But my cosine was squared, so when I replace it, I have to have sine squared. So sine squared of x over cosine of x. Okay, now, when you think of fractions, remember when you're multiplying? If I have sine of x times the sine of x, that's how you would get sine squared of x. So if I'm trying to simplify this as much as possible, I need to realize that when you're multiplying fractions, it's top times top, bottom times bottom. So I could say that this is really sine of x over cosine of x times sine of x over 1. The reason I can't put another cosine here is because my cosine, I just have one of them. I don't have 2. I have 2 sines. So I have the sine of x over a cosine of x and sine of x over 1, because sine of x times sine of x is equivalent to sine squared of x. Cosine of x times 1 is a cosine. So I was able to break this down. Sine over cosine is tangent of x times the sine of x. That's as far as you can actually go. If you're looking at your identities, I could turn a tangent into 1 over a cotangent, or I could have sine of x over cosine of x. This is actually a more simplified version. So again, this is an exception to the rule. We did the process correctly. At the end, we ended up with 2 trig functions instead of just 1. Okay, the next one, just making sure that you are still pretty comfortable with, okay, where can you put those triangles, what quadrant, that sort of thing. That's what the next 2 examples are going to look at. We have a secant that is negative 17 over 15, and we have a sine of theta that is 8 over 17. The secant is the reciprocal of the cosine, and remember your reciprocals will have the same sign. So my cosine is going to be negative. My sine has a value that is a positive value. So if I'm looking at cosine, the cosine is the x value. It's negative, so on your coordinate plane, you're going to the left. The sine is the y value. That's positive, so I'm going to have to travel upwards. So if you think the quadrant where I go left and up, that is quadrant 2. I'm going to go ahead, draw my triangle in quadrant 2. Okay, that's what we have so far. Remember, our theta is always next to the origin. The sine, I'm going to use this ratio in order to label the sides of the triangle. The sine is the opposite over the hypotenuse. So the opposite of theta, this is 8. The hypotenuse, this is 17. What I need to find is the adjacent. In order to do that, remember you use the Pythagorean theorem. So let's call this A, because it's the adjacent. So A squared plus the other leg of the right triangle is 8. 8 squared equals 17 squared. So I have A squared plus 8 squared. 8 times 8 is 64. 17 squared. 17 times 17 is 289. If I minus 64 from each side, 289 minus 64 is 225. If I take the square root of that, the square cancels the square root. It can be positive or negative. The square root of 225 is 15. So now to see if it's positive or negative, you have to look at the location. So from the origin, I'm traveling to the left, so this is going to be a negative 15. Once you know all 3 sides, you can find all 6 trig functions. Remember, across from theta, that's the opposite. Across from the 90, that's the hypotenuse. So the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. The tangent of theta is the opposite over the adjacent. Now we're going to go ahead and look at the reciprocals. The cosecant, this is the opposite over the hypotenuse, so it's the hypotenuse over the opposite. The secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so we're going to have the hypotenuse over the adjacent. The cotangent is the reciprocal of the tangent. Tangent is opposite over adjacent, so this is adjacent over opposite. Now they gave us a couple ratios at the beginning, so this is a good checkpoint. We have to make sure our secant is negative 17 over 15. Secant, it's a negative value, 17 over 15, checks. Our sine is positive, 8 over 17. Sine is positive, 8 over 17, it checks. One more, and here's a scenario we have not looked at yet. They're telling us the cosecant of theta is undefined. In order for this to be undefined, it means that you're dividing by a 0. Okay, so if I think of this, the cosecant is the reciprocal of the sine. The sine is the y value. So the cosecant is 1 over the y. In order for this to be undefined, the y must equal 0. So if you are picturing your coordinate plane, we're not looking inside of a quadrant. Y never equals 0 in a quadrant. Y equals 0 on the x-axis because you're not going up and you're not going down. But remember, on our unit circle, our radius is 1. So I know when the y value is 0, here it's 1, 0, because you're going to the right one unit, not going up or down. Over here at pi, this was negative 1 and 0. So I know it has to be one of those 2 points. The other bit of information they gave us is that the cosine is less than 0. The cosine is the x value. This tells us that our cosine has to be negative. So these 2 options are the only 2 I have because that's where the sine, the y value is 0, so the cosecant would be undefined. But our cosine, our x value, has to be negative, so it can't be this. So here's our ordered pair. We are looking at pi, negative 1 and 0. If I want to find all 6 trig functions, the sine of theta, the sine is the y value, the cosine of theta, cosine is the x value, tangent of theta, tangent is y divided by x, 0 divided by negative 1 is 0. Now we're going to move on to our reciprocals. The cosecant of theta, if I have 0, it's 1 over 0. That's undefined. If I have the secant, it's 1 over a negative 1, which is negative 1. If I have a cotangent, it's 1 over 0, which is undefined. Okay, so there's just a review on where can you draw the triangle. And today you had a scenario. Remember I said today we're going to take things a little bit further. Here you couldn't draw a triangle. We were on the x-axis. All right, let's move on, guys. And turn page. All right. Okay. Here again, we are verifying. And verifying we've looked at before. What you want to do is take the side of the equation that is the most complex. And you need to work on that side and the trig identities in order to get it to match the side on the right. So looking at number 1, obviously this is the more complex side. If you have 2 trig functions, check this out, 2 binomials that contain trig functions, you can FOIL these. I can FOIL this. Secant of x times cosecant of x is secant of x, cosecant of x. Outside, 1 times a secant of x is secant of x. Inside, negative times a positive, now this is negative, this is a tangent of x times a cosecant of x. Negative times a positive is a negative. Tangent of x times 1 is a tangent of x. I need to work with this thing until I get it to equal just a cotangent. So it's kind of fun. Now secant. Secant is 1 over a cosine. Cosecant, that's 1 over a sine. Secant, 1 over a cosine of x, minus tangent is sine of x over cosine of x. Cosecant is 1 over a sine of x, minus tangent is sine of x over cosine of x. So you'll notice I changed everything into sines and cosines. Here, if I multiply those two, top times top, bottom times bottom, I have 1 over a cosine of x times a sine of x, plus, oh, I can't do anything here, cosine of x, minus, hey, cross cancel, 1 over cosine of x, minus sine of x over cosine of x. If you look at the middle 2 terms, this is a positive 1 over a cosine of x. This is a negative 1 over cosine of x. Boom! You can add those together. They're opposites. They cancel. 1 over cosine of x, sine of x, minus sine of x over cosine of x. Now we're down to a point where we are subtracting fractions. You can't subtract fractions unless you have a common denominator. Both fractions have the cosine, but this fraction, you have to multiply top and bottom by the sine of x. So I have 1 over cosine of x, sine of x, minus sine times sine is sine squared of x over cosine of x, sine of x. Your common denominator carries cosine of x, sine of x. The top, 1 minus sine squared of x is 1 minus sine squared of x. Ooh, here you go. This is an identity. If I have sine squared of x plus cosine squared of x, that equals 1. So if I go ahead and I minus the 1 over, so this side is 1 minus sine squared of x because that's what I have on the top of the fraction. When I move that, I can see that this really has a value of cosine squared of x. So the numerator is cosine squared of x over cosine of x sine of x. Okay, so I have it down to there. This means I have two of them. So I have cosine of x times a cosine of x, cosine of x times a sine of x. Well, I have the same thing on top and bottom. This cosine of x can cancel this cosine of x, leaving me cosine of x over sine of x. Check this out. Cosine of x over sine of x is the same thing as a cotangent of x. That's what we were trying to prove, ladies and gentlemen, and we did it. Check. Give yourselves a pat on the back. Give yourself an air high five. I hope you're doing well. We're going to keep going. See, this does get a little intense, but it's really fun. All right, let's look. What I'm going to do, guys, just because I see that the video is going to get a little bit longer, I am going to do this in a part 1 and a part 2. So we're going to go ahead and do 2, 3, and 4, and then I will start a second video so that way it's not so lengthy for you. Okay, let's look at number 2. Whoa. Okay, number 2 kind of looks tricky. So obviously, this side is more complex. You need to change the more complex side to match the more simplified side. So I need to prove that this is really a secant of x. To me, the easiest way to do that, turn everything into sines and cosines. So if I were to do that, the top is 1 plus a cosecant is 1 over the sine. So that's the numerator. The denominator, a cotangent, is the cosine of x over the sine of x plus a cosine of x. Okay, now I know I'm looking at adding fractions on both the top and bottom, so I'm going to try to get this so there's one fraction on both top and bottom. 1 is the same thing as the sine of x over the sine of x. The reason why I would do this is because I can't add these fractions unless you have a common denominator. So the sine of x over the sine of x is equivalent to 1. Now I can add the fractions. The common denominator stays sine of x plus 1. There's the top. Now the bottom, same thing. They want me to add. One of them is a fraction, one is not. So what I did is I put a 1 here. I need a common denominator, so I'd have cosine of x over sine of x. That was fine. This is cosine of x times the sine of x over sine of x. Your common denominator, sine of x, stays. This is cosine of x plus cosine of x sine of x. Okay, so now I have one fraction over one fraction. In math, you cannot divide fractions, so I'm going to keep the top the same. Sine of x plus 1 over the sine of x. Change divide to multiply. Flip the second fraction upside down. So it's the sine of x over cosine of x plus cosine of x times the sine of x. Okay, now check this out. Cross cancel. Look at this. You know that we can divide out common terms now because we've done that. This has a cosine, this has a cosine. I can divide out a cosine of x. Cosine of x divided by cosine of x is 1. Plus, the cosine of x was moved to the outside, sine of x. So I factored this expression down to this. I divided out what they had in common. When you are adding two terms like we are here, there's that commutative property. What that means is I can switch this and say the sine of x plus 1. You can write addition problems in any order you want. So this is equivalent to this. They're diagonal to one another. I can cross cancel this and this. All I would have left is that cosine. So on the top, everything canceled. If everything cancels, you put a 1. On the bottom, the sine cross canceled. 1 plus sine of x cross canceled. All I have left is a cosine. 1 over a cosine. This means the reciprocal of the cosine. It's the secant of x. That's what we had to prove. kind of fun. Take a big breath, shake it out. We got 2 more, and then I'm going to go ahead and start a second video for you. Okay, the next one. Now, when I did this one, I did start off again here, just as we're working through these guys. I know in class we've had quite a few times where you've said, hey, could I do it this way? Or could I try this? And my answer is absolutely. Let's say that you notice something here or a different method than what I'm showing you. Try it. If it doesn't work, you know what? You tried something new. If it does work, awesome. And I'm very proud of you for being able to try different things. Okay, so again, just kind of reiterating as I'm doing these things, there is more than one way to do these problems. Okay, so if you see an alternative method and you want to try it, go for it. Please just make sure that you do end up with the same solution. Okay, all right, if I'm looking at number 3, again, I like to turn everything into sines and cosines. And so the first step is I said, cosecant. Turn that into 1 over a sine minus sine squared of theta. We need to work with this until we prove that it's a cosine squared of theta. Well, this one's going to be nice and easy for us. Sine cancels a sine. 1 minus sine squared of theta. Hey, I have a 1, I have a sine squared of theta. There's this property. It says sine squared of theta plus cosine squared of theta equals 1. Well, if I minus this over, it would match because it'd be 1 minus sine squared of theta. So this has a value of a cosine squared of theta. That's what we're trying to prove, and we're done. So again, some of them are going to be basic. They won't all be super lengthy, take up a whole page of paper. You're going to go back and forth between the 2 options. So it is kind of tricky a lot of times when you do a problem like we just did. This was pretty intense. Then when you get to a problem here and it's so easy, in the back of your mind you want to think, oh my goodness, I totally did that wrong. How can it go from so challenging to I could stand on my head, sing the ABCs, and still do this? That's math for you, okay? It's kind of tricky. It's kind of fun. You never know what's going to happen. All right, last one, and then again, I'm going to do a part 2 for this video, okay? If you see a negative inside of the parentheses, that's where they're looking to see if you have even or odd functions. Remember, if something is an even function, if you put a negative with theta, it's not going to change. It would just be the cotangent of theta. If you have an odd function, it's going to do the opposite. So if you put a negative in with the angle, that negative is now going to carry out to the front. So we need to look at the cotangent and see if it's an odd or an even function. Okay, so cotangent, if you put in a negative like they did, you end up with a negative up front. So it's an odd function. So I can change the top to negative cotangent of theta over cosecant of theta. We need to work on this until we can prove that it is a negative cosine of theta. Again, I think the easiest way to do this, change everything to sines and cosines. So on the top, I have negative. Cotangent is a cosine of theta over a sine of theta. The denominator, a cosecant, is the reciprocal of the sine. You cannot divide fractions, so I'm going to keep the top the same. Negative cosine of theta over sine of theta times. Flip the second one upside down, sine of theta over 1. This cross cancels this. Negative times a positive is a negative. Cosine of theta over 1 is cosine of theta, and it checks. Okay, so we're about halfway through these notes. I'm going to give you a little bathroom break. Go refill your sodas, grab another snack, and I'll see you shortly.